Hi, my name is Alara Derik, and I will be presenting Controlled Queue Generation for Play Scripts. This is a joint work with my co-authors Hilal Dönmez and Pınar Yanardağ from Boğaziçi University. Script generation is a largely unexplored topic compared to story and movie plot generation, and our work aims to address this. A play script typically consists of dialogues and cues, which describe everything that is not spoken aloud. Our main motivation is to enable attribute-controlled script and queue generation using large-scale pre-trained language models. To achieve this, we use a large theater play scripts dataset scraped from the Play Scripts website. We introduced the novel task of queue generation from dialogue lines and use pre-trained language models and frameworks such as PPLM for fast text generation. Furthermore, we extend plug-and-play language models, PPLM, with 3 attribute models and show that our approach can generate diverse, coherent, and interesting cues. So what is a cue? A cue is any unspoken line. It can be a trigger for an action, a description of the stage, or thoughts or body language of the characters. For this work, we scraped over 1,500 play scripts from the Play Scripts website. These scripts have various themes, such as Greek, satire, drama, etc., and contains hundreds of thousands of cues and dialogue lines. We use 3 different frameworks for cue and script generation. Firstly, we use a GPT-2 medium model fine-tuned on our play script dataset. Secondly, we use ILM, which enables GPT-2 to infill variable length spans using both preceding and subsequent text. For this, we use dialogue queue dialogue line triplets to train ILM and generate cues. Lastly, we use PPLM, which enables attribute-controlled text generation on the fly. We extend PPLM with 3 attribute models: a queue dialogue discriminator for queue generation, an automatic topic keyword extraction module for topic-controlled script generation, and a multi-label emotion classifier for emotion-controlled text generation. A little bit of background on PPLM. As we mentioned before, PPLM aims to generate attribute-controlled text on the fly. It does this by using a base generative model, GPT-2 in this case, and plugs an attribute model P of A to sample from the resulting conditional likelihood. The goal is to steer the generated text in a direction that is more likely to generate text with the desired attributes. We propose 3 attribute models. The first one is a single-layer queue dialogue discriminator that can be used to generate either cues or dialogues. We also perform topic modeling with LDA and automatically extract lists of topic keywords for topic control generation. And finally, we have a multi-label emotion classifier. For this, we use Deepmoji to create an emoji-labeled subset, and we map the predicted emojis to a set of emotions, such as happy, angry, and disappointed. You can see some of the input sentences taken from our dataset and the generated results. As you can see, PPLM with the queue dialogue discriminator generates text with interesting cues that are coherent with the input sentence. We evaluate all approaches with quantitative and qualitative metrics. First, we quantitatively measure if the models generate cues or not. To do this, we use n-gram similarity and distance metrics, LCSR and BISIM, and measure the similarity of generated text to a reference queue corpus we created. As you can see, the performance of PPLM with the queue dialogue discriminator surpasses all other approaches and can successfully generate cues. Next, we measure the diversity of generated text, as repetitive text is highly undesirable. To measure the diversity of the generated text by each model, we use the number of distinct n-grams normalized by the length of text. And we report the distinct 1, distinct 2, and distinct 3 scores. As you can see in the table, PPLM with the emotion classifier generates more diverse text compared to other approaches. We also observed that PPLM with the Q dialog discriminator is able to generate cues without compromising from text diversity. Finally, we perform a qualitative analysis with 20 human evaluators. We ask the evaluators whether the generated text can be considered as a cue or not, and we report the results under the cue accuracy metric. Next, we ask the evaluators if the generated text is a plausible sentence and coherent with the input text. As you can see in the table, PPLM with the Q dialog discriminator is not only as successful as the fine-tuned GPT-2 in generating coherent text, but it can consistently generate cues which we have measured to be diverse. In conclusion, we used a large-scale play script dataset and proposed the novel task of generating theatrical cues from dialogue lines. We approached the cue generation problem as a controlled text generation task by using PPLM with a Q dialog discriminator, LDA-based topic keyword list, and a multi-label emotion classifier. We also use a fine-tuned GPT-2 model and an infilling model, ILM, as our baselines. Our experiments show that language models can be successfully used to generate plausible and attribute-controlled text in highly specialized domains such as plays. Thank you for listening.